Hello! Here we are, section 15.2, Law of Cosines. Calculator, degrees. No calculator, no answers. Mode, and then I think it's the third line, the second line, make sure degrees are highlighted, okay? So for all intents and purposes, you are going to be in degrees the whole time until we start to do more extensive graphing next year in trig, okay? So degrees. Here we go. I'm going to ask you the 5 ways to prove triangle congruency. 5 ways to prove triangle congruency. All right? Hit pause. Try and list as many as you can. HL. Oops. Stands for hypotenuse leg. If you have a hypotenuse, you're a right triangle, plain and simple. So if the triangle is a right triangle, you can find the area and all the sides and all the angles using SOHCAHTOA. Okay, another one in no particular order is side, 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 and side, angle, side. No particular order. 2 more are angle, side, angle, and angle, angle, side. If you know 2 angles, you automatically know the third. If you know 2 angles, you automatically know the third. Let's make this very, very clear. SSA. No. That's ass backwards. No, 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 no. Okay, there's a reason why it's a bad word, because it's not a way to prove triangle congruency. Bad ass. No, cannot happen. So, you're probably laughing at home, but this is going to be a way for you to remember that if you know an angle and 2 sides, it is not necessarily, 2 triangles are not necessarily congruent. And we'll talk about why that is in a few lessons down the way. Okay, so today's lesson is on the law of cosines. If you don't have a right triangle, you can always create a right triangle, right? You can drop a hypotenuse. So I'm going to look at side, 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 and side, angle, side today. So side, 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 and side, angle, side. And we're going to use the law of cosines to solve these triangles. What is the law of cosines? I thought you'd never ask. Okay, so we're going to draw a triangle, blah, blah, and I want you to get used to some notation that we use, and your Greek alphabet is going to expand. Okay. A, B, C. Yeah, super creative, I know. And all my triangles look like this. None of my triangles are drawn to scale. So some notation. Opposite angle A is side A. And I may have already told you this, so fine, hear it twice. Opposite angle B is side B. And opposite angle C is side C. Okay, great. Well, where's the Greek? Here we go. So A, the measure of angle A, that's my angle symbol. The measure of angle A is known as alpha. Mine kind of looks a little like a fish. It's not supposed to. It's supposed to look more like an A. I don't know. It looks like that. You can look it in the book. You can look it up. Everything's on Google. You can Google it. All right. The measure of angle B is known as beta. And it looks like a bee, sort of, with a kind of like a tail, maybe. All right. And then the measure of angle C, the measure of angle C is known as gamma. and it looks like a fancy capital Y. I'll try that again. It's kind of like it has this nice little hook on it. This one's a little bit too small. You are not going to be marked off for your ability to draw the Greek letters, but so you know, you're an alpha, beta, and alpha, beta, gamma. You already know delta, right? Delta, epsilon, zeta. You know theta. Iota, kappa, lambda, psi. You know pi. Sorry, I'm doing the alphabet in my head. So pi, phi, chi, psi, omega. You might know omega. That's omega. All right, but we just added 3 letters to your Greek alphabet. Okay, anyway, I'm like dragging on. Here we go. The law of cosines. And there is a proof. You can, I don't even think your book does the proof, but you're obviously welcome to look up the proof on Google. All right, so here we go. You have to memorize it. You know, I'm so anti-memorization, but this is a case where that's just how it has to go. Okay, let's start with the Pythagorean theorem. Let's start with the Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared is c squared. Okay. Okay? All right, we're going to add on to this. Minus 2. You have 2 sides right here. You have side A and side B. So you have 2 sides, 2, and you have side A and B. So we're going to multiply A and B times the cosine of angle C, which is gamma. Your book's going to use ABC. I think you should get used to the Greek. I like it. Cosine of angle C. That is the law of cosines. So it's the Pythagorean theorem minus, the biggest mistake I see students make is they put plus instead of minus, and then you know it's cosine, it's the law of cosines, but then on your calculator you accidentally push sine, so be careful of that. There are 2 other variations. So of course with my pretty colors, this is going to be a squared equals b squared plus c squared. This is just a variation. Minus 2, the sides are b and c, times the cosine of angle alpha. A alpha. All right, and then push pause, do the 3rd variation. And that is b squared equals a squared minus 2ac cosine beta. These are the 3 variations, okay? All you really need to know is one of them. So I'm going to go through 2 examples using side, 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 and side, angle, side, and we'll go from there. You need to know an angle and its opposite side. And so what's that look like? And make sure you have your calculator. Okay, so let's start with side, angle, side. So side, angle, side means you know the angle between the 2 sides. So it's 2 sides and the included angle. So how about we do, let's say that side A is 10 and B is 7. So if you're going to use side, angle, side, I have to give you gamma. If I'm going to use side, angle, side, I need to know angle C. So how about 39 degrees? Okay, now it's literally a plug and chug. So you know angle C, gamma, that's here. I know A, I know B, I know A, I know B, I know gamma. All I gotta do is plug in and I can find side C. Side C. All right, so C squared is equal to A squared plus B squared minus 2 times 10 times 7 times the cosine of 39 degrees. 100th, please. Unless you are told otherwise, you need to do hundredth. So plug in. Don't forget to square root. $149 minus 2 times 10 times 7 cosine 39 second squared second. 6.34. 6.34. Hopefully that's right. Seems realistic. You can also check by doing the triangle inequality. 10 plus 7 is 17, greater than 6.34. 6.34 plus 10 is greater than 7, and 7 plus 6.34 is greater than 10. And there you have it. This is literally a matter of knowing the formula and plugging in. So that's side, angle, side. Let's look at side, side, side. Okay, how about, let's do side A is 16, B is 11, and C is 9. 20 is greater than 16. Boom, boom. Okay, hopefully it works. I think I made up an example in one of these videos that didn't work. Okay. So I want you to find the measure of angle, let's do beta. Let's find beta. Okay, so if I want to find beta, that means I need to use the formula that involves beta. And the formula that involves beta is with B. So B squared equals A squared plus C squared minus 2AC cosine beta. And remember, beta is the measure of angle B. You're going to see it written most like that most of the time, but I like to use the Greek because it makes us feel much smarter. All right, here we go. I know B, I know A, I know C, I know 2, I know A, I know C. The only unknown is B, which means I can solve for it. Okay. We're going to do a derivation of how do you solve for angle B, beta. Miss Babiak, can't I just plug in? And the answer is yes, but most of you are going to mess up the order of operations. So for example, let's just do it this way as is, and I'll explain to you what I mean by order of operations. So B is 11, A is 16, C is 9, yes? So you get 121. I'm going to show a couple extra steps. Okay, I believe 16 squared is 256. It is. 2 times 16 times 9. 288 cosine B. Okay, so here's what happens. Correctly, you would say 256 plus 81, 337. These are not like terms. I cannot tell you how many times people will say, oh, well, 337 minus 288, and they'll say that this is 49 times the cosine of B, and that is not right. They are not like terms. So if you're pretty strong in your algebra skills and you're confident that you're not going to combine things that aren't alike, fine, do it this way. I am going to teach you the derivation of how to find the angle in a minute, which you should know how to do anyway. Here we go. Subtract 337 from both sides. 337. negative 216 divide both sides by negative 288. Oh, wow. It came out really nice. It's 0.75. So you get the cosine of angle B is 0.75. You need to use the inverse. You're working backwards. I know the value of the cosine. Give me the angle that goes with it. I know the value of the cosine is 0.75. Give me the angle that goes with it. So this becomes beta is the inverse cosine of 0.75. Okay, inverse cosine. 41.41 degrees. Okay? All right, let's do the derivation of how to find B, where you can just do a straight plug-in into your calculator. Ms. Babiak, do I need to know how to do this? Yes, actually, you do. Knowing how to manipulate an equation and make another equation is important to do. So I'm going to start back here, and I don't think you can see the green. All right, hopefully you can see the brown. Not much better. I'll use black. I want to make sure you can see it. It's just an excuse to draw on the board with all my different colors. It's much nicer at school. I can use every color. I certainly can't use orange here. Okay, here we go. Okay, you can plug in and you can get the measure of angle beta, and hopefully I plugged it in correctly and I get 41.41 degrees. Yes, that's doable. Let's manipulate the equation. So, essentially, I want to solve for beta. I want to solve for beta. I'm going to subtract a squared and I'm going to subtract c squared. Okay, I'm going to divide by negative 2ac. Okay, right, we don't like the negative in the denominator, and that's why many times when you're quiz or a test or whatever, and you leave it, whatever it is, divided by negative 2, and I tell you that's not simplified, no negatives in the denominator. Let's move it up. So, this becomes b squared divided by the negative becomes negative b squared plus a squared plus c squared over 2ac. This positive became a negative divided by a negative is a negative divided by a negative is a positive. Here you go. Okay. So I want to find the angle. I know the cosine. The cosine is this mess right here, right? It was 0.75. That's an exact numerical value. Here it's a big, a bunch of variables, but it still represents the cosine of this angle. So I'm going to do the inverse in order to find out what beta is. So beta is equal to the inverse cosine of a squared plus c squared minus b squared all over 2ac. Okay, so what you need to do right now is check. Let's check to make sure I didn't make a mistake, that it's 41.41 degrees, and let's plug in to practice using this new formula. Okay, so on my calculator, I'm going to do the inverse cosine of a squared. So a squared is 256 plus c squared. C squared is 81 minus b squared is 121 all over 2. A is 16, and C is 9. Make sure you're using parentheses along the way, but on your calculator you can legit just do inverse cosine and type in parentheses 256 plus 81 minus 121 divided by parentheses 2 times 16 times 9 plus parentheses 41.41. Okay, so there's today's lesson. Right in time for Titus to Mark to tell me that he's had enough. See you next time.